Hello guys and welcome to this video. This time around we're going to be taking differentiation by first principle. So it is normally given with general formula such that the limit as delta x tends to 0 of a certain function f of x plus delta x minus f of x ordered on delta x. So this is how it is given. Let's take an example to see how this can be applied. So it's going to be as such: differentiate x squared with respect to x. So if we are asked to differentiate x squared with respect to x, it's going to be simply this. We are going to first of all write down what our f of x is and what our f of x plus delta x is. So let's write it down. So we know f of x is given as x squared, and f of x plus the x is simply going to be what replacing this x by x plus dx. That means what's inside here, we replace it with this, like in functions. So we are going to have, replacing it, we're going to have x plus delta x, all that squared. So now let's write it back in the form of general equation. So we are going to have the limit as delta x tends to 0 of x plus dx minus x squared ordered on dx. So, and squared, sorry, here 2 is squared, sorry for that. Opening this equation, opening that, we're going to have x squared plus 2x dx plus dx ordered squared minus x squared ordered on dx. So we clearly see here that x squared here can go away with this. So writing it back, we're going to have as the limit as the x turns to 0 of, since this guy and this guy can go away, simply going to have 2x dx plus dx all that squared all that on dx. So now we have that from the equation. So let's factor out delta x since it is common in the equation. We simply still write lim of delta x tends to 0 of delta x all that into 2x plus delta x all that on delta x. So we see here that delta x goes away with delta x, and we can write our equation as the lim of this turning to 0 of 2x plus delta x. Here they is saying, study the equation again very well to understand what's here. Here we can clearly say that the limit of where delta x tends to 0 of 2x plus delta x. So we're going to replace delta x by 0, which in where we're going to have 2x plus 0. And we clearly have what? 2x. And that is the differentiation of x squared. Now, to check if our answer is correct, remember we did the differentiation of polynomials, and this is a polynomial. Let's do it. A polynomial is simply given by dy on dx is equals to na x n minus 1. So we had to differentiate x squared. So as for the derivative of x squared, which is simply going to be what? Let's apply this our formula. N is equals to 2. So we'll bring the 2 down. Ax into 2 minus 1, where we have 2 to the power 1, which is the same as 2x. So always make sure you use this part to check if your answer is actually correct if you're using the first principle. Thanks for watching this video. Comment and share the video, like, and don't forget to subscribe please to produce more. Tell us your problems so we're going to help you. Thanks.